All right, awesome to hear. All right, next up, we're going to learn about Clojure, a static site generator with a Clojure template language. We'll explore what Clojure does, how it works, and how others can design tools like it. Let's hear from someone who enjoys thinking about how to make computers more useful and fun. Please give a warm welcome to Jynn Nelson.
Thank you. So I'm Jynn. I built this thing called Clojure, which is a static site generator, in a way, and it's got Clojure, which is weird. You look at that and you think it's weird, and you're right. So I don't normally do who am I sites, but in this case, I think the context is relevant. I do not have a Clojure background. I work on the Rust compiler. That's my full-time job. I work on build systems a whole bunch, including the build system for the Rust compiler itself, as well as various other build systems. And I write a bunch about Rust, about build systems, about other things. And all of that, surprisingly or not, will become relevant later in this talk. Right. And then I wrote my own static site generator. So I expect a lot of talks today to talk about like Clojure, start with Clojure, and then to talk about the problem they solved using Clojure. I'm going to go the other way. I'm going to talk about the problem that I'm solving, and then I'm going to talk about why Clojure is the right choice for that problem. So let's talk about static site generators. What is a static site generator? Well, let's look at some examples. We've got QuickBlog, written by Michael Bortent, who wrote Babashka. We have Jekyll, which is natively supported by GitHub. We have Hugo, which is popular. We have Astro, and Docusaurus, and Gatsby, and Eleventy, and Hackle, and Zola, and the other Zola, and and XJS. So I got these names from a list of SSGs online that had 378 entries. Comparing 378 SSGs one by one is not going to work, clearly. So we have to instead compare the features that they have. And one feature you might care about is the input format. So for example, Markdown or restructured text. Or if you're from the Racket community, you might care about Scribble as an input language. We care about output formats, usually HTML or PDF. Occasionally you'll compile to SVG or something like that. Sometimes you care about like, image resizing, stuff like that. Template languages, Jinja and Handlebars likes are very common. JSX is pretty common. If you use Hugo, you probably use Go format strings. There's a weird thing called Haml, which uses CSS selectors as the template language. And if you're crazy enough, you can use C preprocessor. I know several people who have built their own SSG from scratch just for themselves using C preprocessor and nothing else, which is a decision. And then we care about how easy it is to get started. So for example, we want the built-in templates and themes to have the things that you need for your site, whether it's a blog or something else. We want you to be able to just like drop a file somewhere and have that work without having to figure out where it goes. And you want the error messages to tell you what's gone wrong and how to fix it without spending a whole bunch of time debugging. And then finally, you might care about extensibility. Now, what do I mean by extensibility? Well, here's some quotes from some static site generators that have extensibility that explain it in their own words. This is Hackle. Hackle says that you can create compilation rules in a Haskell domain-specific language. Pollen says, the book is a program. Eleventy says, you can execute arbitrary JavaScript to fetch data at build time. There's something called Supo, which you probably haven't heard of. It says, Supo works on the HTML element tree level, which enables many use cases and features that are impossible for other SSGs. This is a bunch of different things, and they all sound pretty weird. What do they have in common? What they have in common is programmatic manipulation of your site. So you're taking, your markdown files, your templates, all these things, and you're manipulating them with code. You're looping over them. You're doing various things with them. Why would you want that? Why would you care? Well, here is a screenshot of my own site, Jynn.dev. It has a very weird layout. You can see it has a list of posts. The list starts with 0. They're subdivided into categories. Here's the first, and then the second. And you can see that the numbering actually carries over between categories. It doesn't reset. And if I were to hard code that in my site, it would be doable. It would be a fair bit of work, but it would be doable. But this is actually not hard coded. This is actually generated from a list of posts dynamically. So this is one view of it, and if you go to my homepage, you will see a different view. So this is generated by a bunch of templates. And then you might care about syntax highlighting. So there's two main ways you can get syntax highlighting for a site. The first one, which most people do, is to just throw highlight.js on your site, and it takes care of all the nice things for you. And the problem with this is that if, one, you're shipping a big JS bundle to your visitors who might not like that, they might be on low-grade phones. But two, if you're writing a tech blog, you probably have some people visiting your site who have JavaScript disabled, and now they get annoyed that they don't have highlighting. So the second thing you can do is you can treat this as part of the build of your static site, right? And you can build the highlighting at the same time as you build all the posts. The problem here is that your options are not great. I know roughly 3 options. You have Syntact, which is a Rust library that parses like Sublime text annotations. You have Tree Sitter, which dynamically loads at runtime using the C, ABI, and ELF files. Don't get me started on that. And then you have JHighlight, which works for about 6 languages and is kind of sort of maintained. So what you end up doing in practice is you use pigments, which works, and it works well. And is in Python, so calling it from Clojure is hard. So you might want to spawn that as a subprocess and get its output back into your site. You might want to build a PDF as part of your site. So this is also a screenshot of my own site. This is an article I wrote for a magazine called Page Out. So it's published both in the magazine and it's embedded here on my site with additional links. And I wrote this PDF in Typist. So it's compiled from Typist to PDF. And one thing I might want is live reload for that Typist, where I add some paragraph, and it immediately shows up in this PDF embedded onto my site without additional build steps. And you might want to customize footnote layout. Everybody has a different opinion on how footnotes should work. Nobody's going to agree. Whatever you pick. But what you can do instead is you can let them choose their own layout, so it is no longer your problem. Right. And then the last thing you might want to do is you might want to build libraries in user space. So this is a table of contents from a post I recently wrote for my work, actually. This is about a compiler plugin that looks at a Rust program and detects the entire call graph, starting from main and working out to the leaves. And these sections here, this table of contents is built into the static site generator. It has first-class support for this table of contents. And if it didn't, in most SSGs, you are just out of luck, right? I want an SSG where I can build this in my own site without needing the author of the SSG to have thought about it beforehand. Right. So let's talk about template languages. I'm going to take as an example the weird layout I had as the first example, which had the different categories and the list numbering that continued over. The basic idea here is we find all posts with a specific tag. In this case, the tag is computer of the future, and it's in the front matter for each post. Then we're going to group them by a category. I have 3 different categories. And then we're going to sort them within their category with a pre-specified order. So the order here was very important. And this is some real code that I really did write and is currently running on my site for Jynn.dev. I don't know about you, but this is not my idea of a good time. This is Zola. It's doing a bunch of stuff. It's converting back and forth between strings and integers. We don't have a map function, so every time you traverse a list, you write a bunch of boilerplate. And you actually cannot create new data structures in Zola. You cannot create new maps. So you have to do weird things. In this case, I actually ended up hard coding the keys to the dictionary because that was easier than doing anything else. And of course, Zola doesn't let you build libraries. It doesn't let you customize the rendered markup. It doesn't let you run build commands. You can kind of build themes with it, but the themes are tied to the Zola language, which of course is incompatible with every other SSG language, even though they're all mostly the same. And so now you have to spend effort porting between them when you switch SSGs. I did in fact do this 2 years ago. Not my idea of fun. Right, so that's the current state of SSGs. I think it will be obvious that I'm not happy with it. So what did I do? I wrote my own. Now there are 379. Right, so if that wasn't what we wanted from a template language, what do we want instead? Right? There are other template languages, but they're all the same basic idea of here is some handlebar syntax with the double curly braces, and we're going to embed that into an HTML file and then spit it out. But that bars off a lot of possibilities we might want. So what might we want? We want it to be concise. We don't want to have to think about it every time we see it. We want it to be easy to type. We don't want it to be line-oriented. And this one is actually specific to templates, right? You want to say, if this is a bullet of a list, you want to be able to say just the name of that without having to dedicate a whole line to that. And this already rules out things like Python and Rust and such that really care about white space and indentation and lines because they don't adapt well to this format. And we want to be able to use libraries for it. That's something I care about, at least. And most template languages just don't let you use this. And so when I looked at all these constraints and I was like, I want all these things together, what I ended up with is Lisp. So when I wrote Flower, I gave you a language. That's Lisp. So this is the same code from before, but rewritten from Zola's template language into Flower. And it does these things. It groups the posts by category. It sorts each category by this specific order that is in the metadata. And it actually has an assertion in here. This is not something you can get from most template languages because they just don't have the mechanism for this. Right. So it's still complicated. This is still doing a complicated thing. There's a lot of code on this slide. But unlike before, it can use Clojure standard library. It can create maps, it can create lists, it can use functions in the standard library for operating on those without having to rewrite everything from scratch every single time. Right. So I named this language Sunflower. Here's a smaller example so you can get a grip on it. This language has a lot of weird features. So first it has Unicode characters as delimiters. This here is a Unicode diamond, sometimes called a lozenge. And that says this is a Clojure add-on. So it's doing a Clojure function call to def, which you're all familiar with. And then that immediately goes on to some HTML that is embedded directly below, right? And so next we have that diamond next to an identifier, and that says take that Clojure variable, stringify it, and then embed it into my template. And then we have a for loop. And the for loop, again, is using this diamond. And notice here these weird little guillemets is what they're called. It's like French quotation marks. And this says we're going back from a Clojure context into a markup context. And so here is more HTML below. And you can nest this as deeply as you like. So notice within that HTML, I actually have even more Clojure identifiers. So you can keep having nested for loops if you really want to. And the motivation here is that the diamond and the guillemets are not going to be mistaken for anything else in your site. You're probably not writing any post that uses those things. But both of those things, actually, because the guillemets are only interpreted if they're after the diamond. Right, and so this is the Flower code. And this is what it looks like after it's deshowed. So the Flower binary is taking the template language and it's turning it into Clojure that looks something like this, which I think is pretty readable. There's a little bit of compiler magic to make it so that arrays are properly stringified instead of showing up as square brackets. But on the whole, I think like the transformation, the correlation between the two is fairly simple. And you might look at this and you might be like, okay, sure, I guess that works, but can't we just use Hiccup? Like we have a library for writing HTML, it does do the thing. And yes, you totally could. But if you use Hiccup, now you have to take whatever site you already have, and you have to rewrite it from HTML into Hiccup's little DSL, which is a lot of work that you might not want to do. So this Flower template language lets you incrementally transition from a site you already have into this new syntax without forcing you to convert everything at once. So this brings me to my next favorite feature of Flower. So far I've been showing you HTML templates because that's what other SSGs let you template. And if you want to do this in the post itself, you usually need a shortcode or a macro or something by a different name. And usually those shortcodes behave differently from the type of language. So now you have two different languages to learn. I looked at this, I said, this is silly. I'm going to give you the same language everywhere. So this is the Flower template language in a markdown file. It's the same syntax. The only thing different is that this markdown code here is a different syntax than HTML. Otherwise, all the Clojure rules, all the templating is exactly the same. And because I had been learning Clojure and I think that REPLs are cool, I built a REPL. So you can paste some stuff into the Flower REPL and it will print it out to you exactly as it would show up in your own source file, which I think is pretty cool.
That's cool.
But I wanted to go further than that. I wanted to let you design every part of the site yourself, to give it good defaults so that it works out of the box, but to let you override the defaults if you want to. So here is another snippet of real code for my site. This is the nav bar in the top right. This has a link to all the different sections like about and talks and posts. And this bit here is not so unique. You would see something basically like this in any template language. But it's got this little categorize thing here. It says take the pages, categorize them, and then give me back the sections. How does that work? This uses a Clojure library. In fact, you can use any Clojure library in Flower as long as it runs on Babashka. You do have to vendor it into your own site, but it will run Clojure files. You don't have to learn any special language for this because you can use the language that you already know. And the second thing I want you to notice here, Flower is not making any assumptions about the structure of your site. So here it says a section is defined by whether it has index.html, right? Like, that's how it determines what's a section, what isn't. But you can write a different function here. You can override this and say, oh, actually sections are things that have a bit of metadata in the front matter. That totally works. Nothing here is being hard-coded into the SSG itself. Right. Another thing you can do with this, you could, for example, say I want drafts in my site, and you can write that using metadata, using Clojure libraries and filters like this, without needing them to be a first-class feature of the SSG. You can have them be extensible metadata that's interpreted at runtime. So, speaking of Clojure, Flower is written in Clojure. Flower is not using Babashka. It's a standalone binary. It's not running as a library. What it's doing instead is it's using SCI as a library. And what it allows it to do is to have that HTML with embedded Clojure as the top level language, right? You don't need that to be inside of a macro because Flower is directly interpreting it. It's not a library, it is a top level compiler. So that's neat. Another advantage of this is it gets near instant startup times using Graal, just like Babashka, so you still have very low millisecond starts. And you can reuse code between Flower and your site. Because they're both written in Clojure, and because they're using the same libraries, often the process of taking something from your own personal site that you who've never heard of me have written and moving it into Flower is just copy pasting it over because they're writing the same code. And this is great because it forces me to dog food my own language, right? Like whenever I write a new feature, I think about how would this work in my own site. Right? I don't have special privileges as the author of the SSG. Right, so let's go back. Speaking of SSGs not being special, let's go back to our PDF problem. How do we tell Flower, run this command to create this file, and rerun that command whenever the input file changes? Well, here's what dataflow normally looks like for an SSG. You have markdown as an input, that gets transformed into an HTML fragment, it gets combined with a template, you end up with a page. And here's what our new dataflow looks like. We have typist added, which gets turned into a PDF, which then gets combined with both of these. Does this look familiar to anyone? This is a build system. We're describing the build system. We don't normally think about SSDs that way because the build graph is hard-coded into the binary. But the second we want to not hard-code things, that's exactly what this turns into. Think about live reload for your site. If your SSG doesn't know about all the inputs to your site, it can't propagate live reload all the way through to your browser. It really needs to know the graph all the way through, not just to know the outputs. So, how do we tell our SSG about our inputs? We write a build script. So this is a build.clojure. This is not a normal build.clojure that's loaded by your deps.udn. Instead, this is interpreted by Flower. And this is just a data structure. This is just a map that will eventually get passed to a Flower library call. And because it's a data structure, you can generate it in any way you want with lists, with loops or maps or anything like that. And notice here that it has this little dep file thing. That dep file is the magic that tells Flower, these are the input files I depend on. And that allows you to get live reload. And that means you can get live reload for any command that you can run. It doesn't have to be something that's a first-class feature. So that's Flower today, as it currently exists. It is a thing that you can download and run from my site, flower.jynn.dev. And I want to talk about now about my future plans for Flower. But first I want to talk about problems I ran into while writing Flower. So one, not a lot of people are using SCI as a library. I want to give a really big thank you to Michael Borkent for lots and lots and lots of help getting started with SCI. Graal has really bad build times. It does not have incremental builds, period, which means that you end up with about 90-second iteration times, which is really painful. You can a little bit get around this by writing unit tests, which can use normal like cowwatch, which has fast feedback. But the second it doesn't fit into a unit test, you're in trouble. There is some work on this. There's this thing called layer caching that the Graal team is working on, but it's very experimental and I haven't used it yet. I messed up while I was writing Flower. I managed to make the build script control so many things that had a dependency on which files were in the site, and then emitted a list of which files are in the site, which then required build. Right, so now you have a fixed loop. Let's not talk about it. It was right. And then I'm not satisfied with my template language. The real problem is that it's white space sensitive, which is a problem for other template languages, but it's less of a problem because they're usually templating HTML, which is not sensitive to white space. If you want to use it for Markdown, suddenly this becomes much more of a concern. There are languages that will have like little dashes next to the curly brackets that says remove the white space. I think that's really error prone and not something I want people to work with. So what I'm doing instead is I'm writing a new language, which I think will hopefully solve these problems. I'll talk about the language later, during the questions maybe. So, yeah, so that's what's next. I'm going to build a new language. And I want to note that people are using Flower to build real sites. I know someone at NVIDIA used it to post a blog about a week ago, one of my friends. I know someone using it for a House of Representatives re-election campaign. So people are taking this. I actually need to get back to them on their next packages. Right, and then the last thing I want to do is I want to make it so you can use the template language without having to use the SSG itself. So if you are using something like 11T or Hackle, which has first-class support for external tools, you can use Flower there too, without needing it to be the build system. Okay, so that's all. You can find more info on Flower's site, and you can find the slides for this talk on that URL as soon as I post them, so I forgot to before this talk.